Hello, welcome to my course Six Sigma Analytics with RStudio. This is Moses Gumadi, and this is the first lesson in which I would like to talk about the basic philosophy of Six Sigma. Most of the misapprehensions about Six Sigma and misunderstandings of Six Sigma is due to this word six. And let's get rid of that word six, okay? And basically focus on the core principles that underlie the philosophy of Six Sigma. If rightly applied, it works as well as physics works. Because in fact, the principles we are discussing are as good as physics. Okay? So let's begin with the first principle, which is every system runs on a network of measurable causes and effects. We're talking about causes and effects, and they are related to each other in a network, not just a one-directional thing. It could have a complicated network, which is why people did not understand. And let's look at how these causes and effects are related. The simplest understanding, of course, is that you have multiple causes resulting in a single effect. Okay, everyone gets that. We also know that we have known causes, and sometimes we may have unknown causes, which if we don't take into consideration, sometimes we may have problems, but the fact is we don't know them. That's the fact. Okay, single effect is pretty straightforward. Multiple effects, some people do know that and do consider in their problem-solving techniques. There is a single cause, but it might affect two different things. For example, accelerating very fast can result in increase in speed, obviously, that you want to increase in speed, but also brings down the miles per gallon. Okay, so it's quite straightforward. Now, a slightly tricky bit here is that interdependent x's. Although these two x's are related to the y, but they themselves might have interdependency. Okay, so an increase in x might cause the x2 to decrease, or maybe they both increase together to somewhat. You could have different kinds of relationships between the causes themselves, and that is when we call it as interdependent x's. And these things do occur in nature and also socio-technical systems. Feedback, that is, the x's cause the y, the effect, but the effect itself causes a feedback loop onto one or more causes, and therefore this sort of a thing basically makes the system dynamic. It goes up and down until it stabilizes at a stable point. Okay, that's how it works. This is quite a tricky thing, and you need experts to deal with this sort of a relationship. And these do indeed exist in many systems, many socio-technical systems, many physical systems, engineering systems, even biological systems. Here is another one, counterintuitive effect. A single cause resulting in two effects, y1 and y2, which in turn has a super effect, which is y. The only thing though is that the increase in x causes the y1 to increase but y2 to decrease. And because of that, we can't quite tell whether the final y is going to increase or decrease. Sometimes it'll be a little bit tricky to determine that, and so that's why we're calling it as counterintuitive. And the reason is because of this sort of a scenario where this red one, the green one, is y1 increasing with x, y2 actually decreases with x, but the total y, it comes down but increases. So the question is, does y increase or decrease with x? It depends. It depends where you are. Okay, this is pretty straightforward for people who understand mathematics or physics, but unfortunately in the industry, when you talk about Six Sigma, not everyone knows these things, which is why there's a lot of confusion and a lot of, I would say, misapprehension about it. Right, one more, delayed effect. Causes, once a change is brought and sustained, effect doesn't kick in immediately. It'll take a while, but once the effect kicks in, it'll remain. You could also, if this is a sudden kick in actually with a delay, you could also have a gradual kick in, which I have not shown. Okay, that is possible as well, a delayed effect. And the delay is due to the inertia of the system. Inertia is essentially the resistance of the system to change. So it takes a while for it to pick up speed and come to that position. Trigger effect is similar, except that the change is not sustained. You just press it and it comes back to normal, right? Just as in a push button or a trigger of a gun or a pistol, but the effect remains. Okay, until of course in some cases where again you push back and the effect is reversed. So you could have this kind of cause and effect relationship as well. Let's come to the second point. Outcome variability is due to known variability and randomness in X's. What is outcome variability? The outcome or the final effect that we want to see, right, doesn't come with a single value, because we are talking about a measurable outcome or measurable effect. And it has multiple values, especially if you're producing multiple goods or if you are running the service multiple times. The values, the measurable values, will have a range of values. And if you plot them like a histogram, which is what we see here, the length of the column being the frequency, how many times you have this value, etc. So all these blue values and red values are the number of times they occur, and this green box is the range within which we want the Y to be, and these dark brown are the ranges where they are beyond. So they are beyond the specification limit. LSL, USL are upper and lower and upper specification limits. And so here, if you say roughly it is 82% on target. So the blue area compared to the total is 82%. But what you would really want to do is to bring down this spread into a bit more narrowed, as narrow as possible to the target, right, within the target range, to reduce the overall defects or overall, items or overall instances where it goes beyond the specification limit. Here you can see from 82 it comes to 97. That's the outcome we're talking about, and the outcome has a distribution, and this is the distribution, right? The histogram that you see is the distribution. But why is there variability within the outcome or the effect? It is because of the variability in the causes. It's very simple. This is therefore one of the fundamental principles of Six Sigma. Mathematically speaking, when X's are related to Y, okay, and if we have variability in the X's, it results in outcome variability. Very plain and simple. You can even calculate how much it is if you know the relationship between X's and Y. Now, there are three types of variability here. One is that the variability of X1 here has known causes. We know this is the variability, and we also know why is X1 varying like this, because X1 has additional causes, underlying causes, and they must be varying due to which X1 is varying. So we have known causes contributing to the variability. The second scenario is we don't have any known causes, and most likely we think it is noise or random variability. Okay, there is a systemic natural variation that is occurring at the bottommost X, and we can't really help any further, and therefore we think that X2 has a random variability. You can't do really much about it unless there are other ways of arresting it. Third case is where you actually don't know the cause itself, and therefore any variability within that is also unknown. So, but that doesn't mean it doesn't contribute to the outcome variability. It does. Okay. So, but the number 2 and number 3 are similar, except that the number 3, you don't even know the causes. Okay. Now, when you make a change in the X, the changes in the X can be made in two different ways. You can move the mean, or you can reduce or increase the variability, or both. As you can see here, the mean is increased and the spread or the distribution is narrowed in X1, which results in the decrease in Y and the mean of the Y, and also a reduction in the variability of the outcome. So this is the fundamental principle then that underlies Six Sigma. Forget about 6 because the 6 is a measurement of how much you have narrowed it down, but it doesn't matter how much you have narrowed down. The point really is, have you narrowed down enough in order to meet your specification? That's all it is. Okay, right. The third principle then is that identifying and changing a few critical X's often results in huge results. All you need to do is to identify a few critical X's, these red ones. Just ignore all the other yellow ones. They may be, I'm only showing you 3, but there may be many more. So that's the key. Few critical X's. Here we have X3 and X1 as the critical X's. But how are you going to determine the criticality of a particular cause on the effect? Again, using the data. Okay, what you do is, if you make a change in the X by a certain amount, what is the change in the Y? That's what you will determine for every X. In fact, probably all X's together. In complicated cases, you can't do one by one factor. There is a way of doing this thing called Monte Carlo simulation. We'll talk about it later. But so this is essentially it. You change the X and you get a corresponding change in Y, and that will help you identify which of these are the critical X's. The more critical the X is, the more the change in Y because of a certain amount of X. If you change X to 1%, how much percentage change in Y do you see? So the more percentage change you see in the Y due to that particular X, the more critical it is, or the more easier it is for you to manipulate that X. Okay. There is another way that you can identify the criticality of X's, especially in terms of the variability. So when you change the X by a certain amount, or by say a certain percentage, let's say 10% I change my X. How much percentage has my variability, not the actual value of the effect, but the variability of the effect, how much has it changed? That is another way to identify the critical X's. And so we come to this end of this particular short lesson, the basic philosophy of Six Sigma. Every system runs on a network of measurable causes and effects. Outcome variability is due to known variability and randomness in X's. And if you want to achieve huge results, the key is to identify few critical X's that really matter and make the right change within them in order to effect the change that you want. That brings us to the end of this lesson. Thank you very much.